In this video, we're looking at conditional probability. So conditional probability is used to calculate probabilities for dependent events. So, what is a dependent event? A dependent event depends on what's happened before it. So, something has to have happened for us to find out that dependent event. So, for example, here we have a bag that contains 4 yellow and 3 red marbles. 2 marbles are drawn from the bag without replacement. So what this means is, once we've pulled out that first marble, all the probabilities for that second event, the drawing of the second marble, have changed. This is because depending on what I've drawn first, if I drew a red marble, the number of red marbles in the overall bag now is less. So the first thing is that there are a lower number of red marbles, but there are also a lower number of marbles altogether. So, given that the first marble was red, what is the probability that the second is also red? So just to make things a little easier, what I'm going to do is I'm going to actually draw our marbles, and it might make it a little bit easier to visually see what's going on. And then we have 4 yellow. Okay, now that's what we started with. Now we know we drew a red marble. So what I can say is that this marble here we drew, so it's no longer there. Okay, it's gone. We don't need to worry about it. We now need to focus on finding the probability of drawing a red marble from what we were left with. And what we're left with is this here. Okay, that's our new set. So the probability of a red given first was R as well. Remember, when we're trying to find the probability, it's the number, in this case the number of red marbles, so R marbles, over the total number of marbles left. So in this case, we have 2 red marbles left, so 2 goes on top. And altogether, we have 6 marbles altogether. Now, it's important, you always got to remember this, simplify, alright? If possible. And in this case, it is possible, because what is the biggest number that goes into 2 and 6? 2. So, on the top, 2 divided by 2 is 1, 6 divided by 2 is 3. So, the probability of getting a red marble, given that the first was also red, is 1 over 3. Now we're going to look at another example. The same bag with the marbles, except the first event is now a different colored marble. So we start the same way. I'm going to physically draw out my marbles. Obviously you don't have to do this. This isn't a requirement. It's just a good way to start it, to have a visual representation of what's going on, and it can help. So obviously this time what we've done is we drew a yellow marble. And our new data set is going to be this one here. So now we need to do the same thing that we did before. We're going to find our probability of getting red given the first was yellow. Okay? So same thing, we're still looking at red marbles. So the number of red marbles goes on top. And then we have the total marbles on the bottom. So this time we have 3 over 6, and again we can simplify that down to 1 over 2. So as you can see, depending on what was drawn first, because if we go down here, let's write it out. So we had red, red, all right? That ended up being 1 over 3. In our next one we had yellow and then red, and that was 1 over 2. So you can see, depending what was drawn first, does have an impact on the probability of what we're drawing second. Okay? So, drawing the red first, we had a 1 in 3 chance of getting a red again. Whereas if we drew the yellow, we had a 1 over 2 chance of drawing a red. So it's important to note that conditional probability depends on what's happened before.